Okay, last thing in chapter 1 is inequalities. We've solved inequalities before. The only thing that may possibly be different than equalities that use inequalities. Did I say equalities to begin with? All right, that's the first mistake on video for perpetuity. Inequalities. What does that even mean? What are these things going to have that's different than equations? The less than or the greater than, less than or equal to, or greater than or equal to. So that's what we're working on in 1.6. In intermediate algebra or college algebra, we may have taken a day to solve linear equations, a day to solve quadratic, a day to solve linear inequalities, a day to solve quadratic inequalities, a day to solve rational inequalities. In pre-calculus, we go, you've seen this before, let's do one of each and call it good. So, let's review one thing that could possibly be different than the last time you solved an inequality if it was in high school. In high school, Scott's going to high school. That was 90 years ago. In high school, when you solved an inequality, you may have left the answer as x is greater than 4. Or you may have graphed it. If you graphed x is greater than 4, what does it look like? It's on the number line. Everything greater than 4 is to the right of 4. And if the answer was x is greater than 4, does that include 4? No. So how did you show that on your number line? You used an open dot. The only thing different than that and how the answers are going to be written here is the answers are going to be written in interval notation. Instead of writing our answer as x is greater than 4, for example, or on a number line, putting an open dot on 4 and then shading forever to the right. Interval notation kind of looks like an ordered pair, but it's not. In either parentheses or brackets, you put where your graph starts and where it ends. And interval notation is always in the order that it comes from left to right. So if your shading starts at 4, 4 is going to be your first number, and then what symbol do we use in math when we're shading forever to the right? Infinity. To show that that 4 is not included in interval notation, we use a parenthesis. The parenthesis means not including. And if we had on our graph used a closed dot, then 4 would be included. What would cause us to have a closed dot? If the original expression had greater than or equal to, we would have had a closed dot on our graph. What's comparable to that in interval notation is we would have used a bracket instead of a parenthesis. So really all you have to remember is always make sure your interval notation is in order, left to right, lowest to highest. Parenthesis means not including, bracket means including. And all of that is on a chart on page 64. I won't read all of it, but each of those 9 examples gives an inequality written as an inequality, the graph, and then the corresponding interval notation. And you'll see that when the inequality has equals and the endpoints are included, the interval notation will have brackets. When you shade forever to the left, like this number 7, x is less than b, doesn't include the b, so they'll put a parenthesis on the b instead of an open dot. Shade forever to the right, I said as I moved my pen to the left. Shade forever to the left, the symbol for forever to the left is negative infinity. And you would write that answer negative infinity up to b. You would never write b to negative infinity, because negative infinity is always as far as you can go to the left, and then some more. All right, so that's how we're going to write our answers in interval notation. Just a little bit of practice with that from page 73. Number 2, x is greater than or equal to 4. Write the inequality as an interval and sketch its graph. While you're getting used to interval notation, it may be helpful to sketch the graph first. X is greater than or equal to 4 would start at 4 and then shade forever to the right. And would the 4 be included? Yes, because it said greater than or equal to 4. The 4 would be included. In high school, we may have used a closed dot to show that. And it's still okay if you put that on your graph. But if we go ahead and use a bracket instead of a closed dot, that may be helpful because that's exactly what we need in interval notation. What would our interval notation be for that inequality? Oh, I'm glad you asked that. You always have a parenthesis on infinity because infinity is not a number that you can get to and include. It indicates that something's going on and on forever, so there's no ending point that you can include. Always use a parenthesis on infinity and negative infinity. What about number 4? X is, I just read that, X is between 3 and 7. You can throw the words inclusive on there to say that the 3 and the 7s themselves are included. If you read that as an inequality, you'd say 3 is less than or equal to X is less than or equal to 7. But I find it easier just to say X is between 3 and 7, inclusive. So that graph would be from 3 to 7 shaded with both points included, both endpoints included. And that's just what the interval notation looks like. A bracket on the 3, comma, 7, bracket on the 7 means including both endpoints. Number 6 is just going the other direction. Let's take something in interval notation and write it with an inequality. If you can do that, yay. If you need to graph it first because that helps you, then you can graph it first. I know -6 to infinity would start at -6 if I were graphing. Would to infinity indicate shading to the right or shading to the left of -6? Yeah, it's positive infinity, so it's shading to the right. And is the -6 included? No, because the interval notation has a parenthesis on it. I'd put a parenthesis on my graph. How do I use an inequality with the variable x to say x can be anything to the right of -6? What was that? Yeah, just x is greater than -6. So you give me any one of those 3 things. You give me an inequality, and I can change it to a graph or interval notation. You give me interval notation, I can change it to a graph or an inequality. Give me a graph, I can change it to any one of the other 2. They're all interchangeable. So let's talk about the different kinds of inequalities that we're going to solve. And anything that we've done something exactly like it in college algebra, I'm just going to tell you where there's a good one in the book and not write it down so that we can save our time for problems that are a little bit different than what we did in college algebra. My letter A there is linear inequalities. It's an inequality that has a greater than or a less than. What makes it linear? First degree. If it's just x to the first, if that's the highest power of your x's, then it's a linear inequality. And you solve linear inequalities using the same steps that you use to solve linear equations. You clear out the fractions, you clear out the parentheses, you combine like terms, get all your x's on one side, your constants on the other, and then you divide. There's just one caution with a linear inequality. Let's see if you remember what that caution is. If I had, for example, -2x is greater than 6, how would I get that x by itself?
You have to divide by -2.
And as soon as you said divide by a negative, bells and whistles went off in my head to say when you divide both sides of an inequality by a negative number, you have to reverse the inequality. Now, does that sound like something somebody made up 1,000 years ago just to see how many pre-calculus students they could flunk in the year 2017? Yeah, it sounds like that, but it's not. Because think of this. If I, what am I trying to say here? If I ask you to insert the correct inequality symbol between the numbers 3 and 5, what inequality symbol would go between 3 and 5? Less than or greater than?
Greater than.
3 is greater than 5?
Less than.
That's okay. I have my dyslexic moments. Less than would be the right symbol to put between 3 and 5. However, if I gave you the numbers -3 and -5, what would be the correct inequality symbol between those two? You think on a number line, -5 is to the left of -3, -3 is to the right of -5. So the symbol you'd have to have in there is greater than. These inequalities, this inequality is just this one multiplied by a -1. The reason the inequality symbol reversed is not because some dead guy said so, but because that's how the negative numbers fall on a number line. All right? So I don't want you just thinking anything in math is hocus pocus, because the way negative numbers fall on a number line. All right, that caution is actually right above example 1 on page 65. I'm not going to write it down because it's right here. If we multiply or divide both sides of an inequality by an expression that's always negative, such as -7 is always negative, -x² is always negative. If you divide both sides by a negative, then you have to reverse the inequality symbol. And you can see that in example 1. They've gotten the terms with an x on one side and the terms without an x on the other. And the minute they divided by -2, it reversed the inequality symbol. If you remember that, then there's nothing new about solving linear inequalities. So my letter B is compound inequalities, and there's a good one of those on page 66. A compound inequality is just a combination of two inequalities. It's when I like to use the word between. 4 minus 3x over 2 is between -5 and 1, including the -5, but not including the 1. It's almost like solving an equation with 3 sides. An equation never has 3 sides, but whatever you do to one side, you do to all 3 sides. So the first thing you would do is multiply all 3 sides by 2. Actually, they show breaking it apart here to show you both things that that inequality is saying. But down here where they start solving the inequality, they multiply both sides by 2 and then subtract 4 from all 3 sides, and then divide all 3 sides by -3. And again, when you say divide by negative, bells and whistles go off to remind you to reverse those inequalities. And when you write your interval notation, don't just automatically write it in the order it is on this line, 2/3, comma, 14/3. Actually, don't write it in the order that it is here, 4/3, comma, 2/3. 2/3 is smaller than 14/3. So when you write that in inequality notation, it should have 2/3 to the left of 14/3.
So when we switch the signs, we need to drop the negative.
You never drop a negative. You divide by a negative, and when you divide by a negative, yes, that reverses the symbol. It's never drop a negative.
Well,
You're
I
thinking
know, but
something
they're
different,
not
though.
negative anymore.
This was a negative divided by a negative. That's why they're positive. I didn't drop any negative. I divided a negative by a negative, and that gave me a positive. All right, so We've done those before. That's all I'm going to say about linear inequalities and continued or compound inequalities. What we really need to spend our time today on is rational inequalities and absolute value inequalities, because we've never thought like this before. You have one good example in the book on page 66. Example 3. Let's look at it and then do the 2 we have on our paper. Number 60, page 66, example 3 says solve 1 over x minus 2 is greater than 0. What word could you use to describe all the numbers that are greater than 0? Positive. All right. So we're looking for all the values of x that will keep that fraction positive. What makes a fraction positive? Isn't a negative in the numerator or denominator? Actually, what if you had a negative in both the numerator and the denominator? Then it would be positive. So I'm just thinking through some things here. A fraction is positive if both the numerator and denominator have the same sign, whatever that sign is. Either they're both positive or they're both negative. What is true about that numerator in terms of sign? It's positive. So the only way that whole fraction is going to be positive is if what? If the denominator is also positive. So you just solve x minus 2 has to be greater than 0, and you get x is greater than 2. This would fall in the category of squint hard and think about it. There were no steps that I could write down there, but the book shows the exact words that you have to think through to get that solution. If you have a fraction must be positive, then whatever the sign of the numerator is, the sign of the denominator has to be the same thing. So you really only care about what keeps the denominator positive. Let's see if we can squint and think real hard and solve 14 and 16 the same way. Take a deep breath. I like it when I give you step 1, step 2, step 3, step 4. This, I'm not giving you that. We just have to think real hard. What word could you use to describe all the numbers that are less than 0? Negative. And so I'm thinking, what makes a fraction negative? Well, in this fraction, the numerator is always negative. So what would have to be true about the denominator in order to keep the whole fraction negative? The denominator has to be positive. It's a negative divided by a positive that would give you a negative. Okay, so let me see if I can write down anything that helps there. A negative divided by a positive will always be less than 0.
So it just depends on which way the sign is turned.
Less than means negative, greater than means positive. But if the numerators, if you're looking for what makes the whole fraction negative and the numerator's already negative, then the denominator's going to have to be positive. What if that symbol had been greater than 0? If that symbol had been greater than 0, then I'd be looking for what makes this fraction positive. If the numerator is always negative, what would the denominator have to be in order for the whole thing to be positive? It would have to be negative as well. But that's not what this problem is. This problem is must be positive because the whole thing has to be negative and the numerator is negative. So the inequality that I'm solving is the denominator must be positive. I could either subtract 2 from both sides and then divide both sides by -1. That would be perfectly legal. Or I can just add x to both sides and have 2 is greater than x. How would I write that if I wanted the variable on the left-hand side? What means the same thing as 2 is greater than x? X is less than 2. And that makes sense. If I say, what numbers can you subtract from 2 and still get a positive? You'd say anything smaller than 2.
Right.
So in interval notation, what would that answer be?
If you did it the other way, wouldn't you have to divide by a -1, so you would have to flip your sign?
Yes, and watch what happens if I do it that way, because I want to show you that you get the same answer no matter how you think about it. If I subtract 2 from both sides, that doesn't reverse the sign. When I divide both sides by -1, that's when the sign reverses, and that's the same thing I got this way. So regardless which one of those 2 ways you think about it, you come up with 2 is less than x, or x is less than 2.
So you have it saying greater than because it has to be positive.
You mean right here?
Yes.
Yes.
Okay.
Here it's greater than because we figured out the denominator must be positive.
Okay, that's what I thought.
So what is that answer in interval notation? You can graph it if you need to. Until you get really good at interval notation, you can graph it. All the x's less than 2 are to the left of 2 on a number line, and the 2 itself is not included. So I show that with a parenthesis on my graph, and I make sure I have a parenthesis on the 2 in interval notation. The interval notation always goes from left to right. So how far does that graph go to the left? Correct. If you write that graph, then the interval notation looks just like it. Now, this method, which I call squint and solve, there's almost nothing to write down. I tried to write down something so that it would make sense when you got home and looked at it again. But really, if I was solving this problem on my own, I would just say, I'm looking for what makes the whole fraction negative. The numerator is always negative, so the denominator is going to have to be positive. And I can tell you what kind of x's make that positive without having to solve an inequality. Anything smaller than 2 is going to keep the denominator positive. This is the way we say anything smaller than 2 in interval notation. All right, so let's see if we can think through number 16 the same way. Are we looking for what makes the fraction positive or what makes the fraction negative? It says less than 0, and that's our definition of negative. So we're looking for what makes the fraction negative. What is always true about that numerator? The numerator is always positive. What's true about that denominator? What is true about that denominator?
Or no, it's not.
It's a negative. If you had negative x.
Okay. All right. You're saying, and let me see if I understand you right. You're saying if I want the whole fraction to be negative, but the numerator is always positive, then I'm going to have to find what makes the denominator negative. All right. A positive divided by a negative is what I'm looking for. So I want that denominator. I want to find out what makes it negative. Can you squint and tell me what values of x make that denominator negative?
Isn't.
I mean,
Is it none of them?
none of them, because even if you let x be -4, when you square it, you're going to get a positive. And when you add 4, you're still going to get a positive. Even if x is 0, the denominator is still positive. X squared plus 4 is always positive unless you get into the realm of imaginary numbers, and this doesn't say anything about imaginary numbers. So what's the answer to the question? If I'm the boss and I say, you got to find what makes this less than 0, you come back and say what?
There's no solution.
There's no solution. There's nothing that's going to make that fraction negative. And then you just hope I don't fire you. Donald Trump would if you came back and told me that it couldn't be negative. You'd be out the door the next day. But I'm going to trust that you know what you're talking about, and there really is no solution to that inequality. No real solution if I'm being technically correct. All right. Now, the only reason we could do those two inequalities by the squint and solve method is because the numerators were constant. This numerator was always negative, so I only really had to worry about the denominator. And number 16, the numerator was always positive, so I only had to worry about the denominator. In just a minute, when we flip to the third page, we're going to get rational inequalities where the numerator is not a constant, and we're going to have to solve it a different way. I'll show you sign diagrams in just a minute, but I just wanted you to be aware of the fact that the only reason you could solve 14 and 16 by squint and solve was because the numerator was always a constant. Before we get to those sign diagrams, and goodness gracious, we're going to run out of time, let's talk about absolute value inequalities. To solve absolute value inequalities, you just need to understand what absolute value means. And you might have to write this just on separate paper, or you might just need to think about it with me a minute. If I say the absolute value of x is a constant, that means x is c units from 0 on the number line. Absolute value is a distance. So when I say the absolute value of x is c, I'm telling you the distance between x and 0. If I put a number line with 0 in the middle, if I counted c units to the right, where would I stop? I thought you said it's about I'd stop at c. If I count c units to the right, I'd be stopping at c. What if I counted c units to the left? Where would I stop? Negative c. So distance can be to the left or to the right, and that's why this equation has two solutions. The two solutions are, well, x either has to be negative c or it's positive c, whatever c is. When I write absolute value of x minus 2 is 5, 5 is the distance. That means x is 5 units from 2 on the number line. Make sure you understand 5 is the distance. And that distance could be to the right or it could be to the left. So if I started a number line with 2 smack in the middle, and I counted 5 units to the right, where would I end up? Exactly what you're thinking. I started at 2 and count 5 units to the right, where do I end up? 7. If I start at 2 and count 5 units to the left, where do I end up? -3. You can find the solutions to an absolute value inequality by counting on a number line. But if I said absolute value of x minus 2 equals 73, you're not going to want to have to put down 2 and then count 73 tick marks to the right and 73 tick marks to the left. So there has to be an algebraic way of finding those same 2 answers without having to count it out on a number line. Well, you get those same 2 answers if you say x minus 2 equals -5 when I'm counting to the left. That's a distance and a direction, -5. X minus 2 equals +5 if I'm counting to the right. When you solve those 2 equations, you get the very same -3 and +7 that you get from counting on a number line. That's an absolute value equation. What about an absolute value inequality? If I say absolute value of x minus 2 is less than 5, that means x is less than 5 units from 2. And I'm not going to write the words on a number line again. X is less than 5 units from 2. Well, we know where we would end up if we were exactly 5 units from 2. We'd either be at -3 or we'd be at 7. If we're less than 5 units from 2, where would that be on the number line? What numbers on the number line are less than 5 units away from 2? If you're less than 5 units from 2, are you close into 2 or are you far out from 2? You're close in. Specifically, where are you if you're less than 5 units from 2? You're between -3 and 7, not including the -3 and the 7. You're somewhere in this range. Not including the -3 and the 7, because your original inequality didn't include exactly 5. So you would write that answer as an interval notation, -3 to 7 with parentheses on both. But what if you didn't want to have to use a number line to figure that out? You could get the same answer if you just set x minus 2 between -5 and +5. -5 would be 5 to the left, +5 would be 5 to the right. If you added 2 to all 3 sides of that inequality, you'd get the same answer without having to figure it out on a number line. All right, let me show you one more. What if I said absolute value of x minus 2 is greater than 5? That would mean x is more than 5 units from 2. Where would you be on a number line if you were more than 5 units away from 2?
You'd be anywhere except within -7.
Instead of the middle, you'd be both ends. That's more than 5 units from 2. That's over here or over here, not including either one of those endpoints. Now to write that answer, could you write it as a single interval like we did here? No, we've got 2 disjoint intervals. We would have to write them separately. We'd have to write negative infinity up to -3. The union symbol means, and the other answers are 7 to infinity.
So if you had more than 2, would you do it in between all? Not that you would.
Let me say one more thing and see if it answers your question. I'm not quite sure what your question is, so let me see if this answers it. So how do we get that answer algebraically without using a number line? Well, anytime you have absolute value is more than something, you're going to get the ends. So you solve x minus 2 is less than -5, or x minus 2 is greater than +5. That will give you the very same answers in inequality form, and then you can write them in interval notation. Now, that wasn't what you were asking. Tell me one more time what you're asking then.
The unions,
Uh-huh.
put in between the 2. If you had more than 2 answers, would you do that between them?
Oh, yes. Okay, I totally didn't understand your question, but I do now. Yeah, and that's not going to happen with a absolute value inequality, but it could happen with some other kind of inequality. And if I had 3 different intervals, I'd put the u's between all of them. All right, so maybe someday I'll type all that up because it takes a while to write it down, but I like helping you figure out the algebraic way to find these answers, because I don't want you to just memorize absolute value is less than is always the middle, and absolute value is greater than is always the ends. You can do that if you have to, but I'd rather you think distance is less than would be close into, distance is more than would be far out from. And that helps you figure out how to separate the inequality. Now the actual thing in the book at the top of page 68 says the same thing, but doesn't really help you understand why. If I was just reading what's in that box, I'd just have to memorize it unless I had gone through all those examples we just did. But now that I understand those examples, I see why absolute value is less than B means that A is somewhere between, close into, -B and +B. Absolute value of A is greater than B means far out from, more than B units away from 0, then X is less than -B, or not X, A is less than -B, or A is greater than +B. So you have 2 good examples in the book, and then we probably just have time to do the ones that are on the paper. But notice that in example 5, you have absolute value of x minus 3 minus 0.1 is less than 0.04. The first thing you have to do is get the absolute value by itself. So the first thing you do is add 0.1 to both sides. After you add 0.1 to both sides, you say if absolute value is less than 0.5, that means x minus 3 has to be between -0.5 and +0.5. Less than, it's always going to have a single interval answer. You set the argument between -0.5 and +0.5 and then solve for x. But on example 3, when we have absolute value is greater than 9, more than 9 units would be out past -9 to the left or out past +9 to the right. That's why we take the inequality apart this way and solve 2 inequalities and get 2 intervals for our answer. All right, Miss Laurie's looking like she doesn't believe me yet. So let's see if we can do these 3 at the bottom of the page, and then I'll tell you where to stop in the homework. Number 18 says absolute value of x minus 4 is less than or equal to 0.03. Let me turn this into a word problem for you, and it'll make even more sense. And again, she's not believing me, she's rolling her eyes. But what if I said the amount of money in your cash register at the end of the day, look up just a second, has to be less than 3 pennies away from $4? Makes sense. I have to be within 3 pennies of $4. What's okay in my register? Within 3 pennies of $4. $3.97 to $4.03. Anything between those is okay. That's what this inequality is saying. The difference between your balance and $4 must be less than 3 pennies or you're fired. So that means x minus 4 has to be between -0.03 and +0.03. And if we add 4 to all 3 sides of that compound inequality, we'll have exactly what you just told me without making bones about it or writing anything down. You just said you better have between $3.97 and $4.03 in your register. That's exactly what your solution is. From 3.97 to 4.03, including both endpoints.
Only allowed to be 3 cents off, so pretty tight.
I know, I'm a mean boss. 19, absolute value of 3x minus 7 is greater than or equal to 5. That's more than 5 units away from something. Would more than 5 units away be the middle or the ends? So you need to solve 2 inequalities. 3x minus 7 is less than -5 if you're counting to the left, or 3x minus 7 is more than +5 if you're counting to the right. One of those equations, and I'm just skipping a step because that's all I have room for on my paper. If I added 7 to both sides and then divided by 3, I'd have x is less than 2/3. On the other inequality, if I added 7 and divided by 3, I'd have x is greater than 4. So my two solutions are -infinity up to 2/3. Hey, what little tiny thing have I done wrong? But I caught it. Only one tiny thing. Probably get me -1 on the test. What? See that greater than or equal to there? I lost my or equal to. That tells me to include the endpoints. All right, last one, 22 is squint and solve. No steps necessary. Absolute value of 6x minus 5 is less than or equal to -2. For what values of x would that be a true statement? value of X that I put in there and take the absolute value and get something less than or equal to a negative. What were you thinking, Megan? There is nothing that I can take the absolute value of and get a number that's less than -2. Nothing. Great job, Megan. No solution. And for because, all I can think to say is absolute value is always positive. Yeah, I'm going to say greater than or equal to 0, which means the same thing as positive. So where y'all need to stop in the homework, you can't go all the way to 55 odd, but you can stop at, I'm going to say 33. And there's one kind of problem that I want you to just look at the example in the book, because that's all we have time for. Look at this example in the book, example 7, page 69. And then see if you can do 1 through 33 odd.
That's page, which page is that?
Page 70, well, 73.
70.
63 was last night, 73 was tonight.
Did you get my message?
Yes, I did, sir. I answered. I sent you an email.
I'll
Yeah.
look at the email, I'm sorry. I didn't
No,
get any
no.
time.
No.
I just was glad I could make it this morning.
Well, I am too.
You know,
But
I didn't want to get any further behind that.
I,
Not sure what happened. I think it's just over this. I'll work on it.
I
Everything.
lost my dad a couple years ago.
My mom's already gone, so Dad was the last one. And he was the last one in both families.
Really?
But I have 4 brothers and, well, 3 brothers and sisters, so there's lots of family, and we've got my middle brother's in Texas, my sister's in Memphis, and the oldest is in Memphis, my sister. So, I've got to make up the plans for the funeral and everything still, but
Yeah.
took care of Dad yesterday, so one step at a time. And that's the way I live my life that way and have for 18 years now.
It works.
Yes.
It works better than any other method.
Well, the way that I used to do it didn't work at all. It really killed me. And
I understand that.
yeah, I've been sober a long, long time. And it's